Hello everyone, my name is Andrii Boiko. I am a full-stack JavaScript developer at Binary Studio. Today we will talk about the relatively new technology GraphQL for working with APIs, how it works, why it is popular, and write some code examples. Let's start from the definition of what is GraphQL. GraphQL is a query language that was founded by Facebook back in 2012. Since 2015, it became open sourced and started rapidly gaining popularity. It basically defines a declarative way to get the data from an API into your application. It operates in a more efficient manner than traditional methods and services because of specifying which exact data you need. Instead of using several endpoints, it exposes a single endpoint and returns only the data client queried. GraphQL is designed to make APIs fast, flexible, and developer-friendly. So who's using it? Due to official information on the GraphQL website, more than 100 big companies are using this technology, including Netflix, Atlassian, Airbnb, GitHub, etc. In case of developers, according to the information of State of JS 2012 report, 50% of developers who took part in the survey already use GraphQL. Almost 45% are satisfied with the technology and would use it again. Almost 44% are interested and would give it a try. Let's break down piece by piece how GraphQL is used. The main killer feature and advantage of GraphQL is schema. Schema is a contract between clients and server, which defines how to access data. The GraphQL schema is at the center of every server. It defines the server's API, allowing clients to know which operation can be performed by the server. The schema is written using the schema definition language, SDL. With it, you can define object types and fields to represent data that can be retrieved from the API. The GraphQL specification defines a set of built-in Scala types. They are int, float, boolean, string, and ID. Also, we can define custom types in this schema that may represent our data models. Here we got a product and a review type that contain a set of fields, such as ID, title, price, and a text. Each of these fields may be Scala type or another object or arrays. Here we define that a product may have an array of reviews, while review is connected to the one product. This builds a relation between these types. Our scheme does not necessarily have to represent our database structure. We may add some extra fields or hide some at the runtime. Schemas enable automatic code generation, validation, parsing, introspection, and type safety for your APIs, giving it extra value. When we work with REST APIs, each model or operation is represented by a different endpoint. We may view or modify data using these endpoints and HTTP methods, such as GET, POST, PUT, etc. In GraphQL, we have a completely different approach. Instead of having several endpoints, we've got only one that exposes available operation with our API. These operations are called root types, and they are divided into queries, mutations, and subscriptions. First root type is a query, which is an alternative to GET requests in REST. It simply shows what we can fetch from the server, what are the parameters, and what should be expected as a return type. In the example, there are three fields: version, that returns a string; products, that takes an argument filter and returns an array of products; and reviews, that simply returns an array of reviews. Secondly, there is a mutation type to show what operations to change data are available. There are three kinds of mutations: adding new data, updating or deleting existing ones. Mutation also may take parameters and return data. In our case, we may create a product or a review, specify a parameter as an input, and then get a newly created object. The last query type is a subscription. It allows the server to send data to the client when a specific event happens on the server side. Usually, subscriptions are implemented through a WebSocket, so that the client is connected and listening to the events all the time. Client opens a WebSocket connection, specifies events he wants to listen to, and wait till them occur. After that, the client receives data that is defined in the schema. In our case, there is a subscription to the product. Each time the server creates a new product, the client is being notified and receives a new product object. All previous information was related only to GraphQL schema. But how do we get data that is defined in a schema? For that, we should write a request. We can see an example on our left. Firstly, we should specify the root type of the operation. In our case, it is a query. Then, we write the field, that is data we want to get, products, and define at least one field we want to get from the response. It is ID, title, and the price. Then, the server calls for each field its own function, called resolver. It must be defined for every field in this schema. The only goal for the resolver is to get queried data no matter how. It may take it from the database, mock data, or a third-party API. After getting data, GraphQL converts it to the queried format and returns it to the client. On our right, we've got two examples of products resolver. The first one is returning a constant array of objects, and the second one is returning them from the database. Each of these functions is a resolver. After understanding the main concept of GraphQL, let's take a look at its use cases. First one is a simple GraphQL with a connected database. The second one is more complex, when GraphQL is used for connecting different systems into one, such as microservices, legacy system, or third-party APIs. By integrating multiple systems behind its API, GraphQL unifies them and hides their complexity. The GraphQL server is then responsible for fetching data from the existing system and packaging it up in the GraphQL response format. This is particularly relevant for legacy infrastructure or third-party APIs that have expanded over the years and now present a maintenance burden. When migrating from a monolithic backend application to microservice architecture, a GraphQL API can help handle communication between multiple microservices by merging them into one GraphQL schema. While each microservice defines its own GraphQL schema and has its own GraphQL endpoint, one GraphQL API gateway consolidates all schemas into one global schema. To sum up, there are a lot of GraphQL pros. Firstly, it is a solution for uncomfortable data fetching, such as overfetching or underfetching, by providing a method for fetching exact data you need. Secondly, it is a perfect match for microservices as a gateway. Thirdly, it has low bandwidth, so may be suitable for mobile clients where the bandwidth matters. Also, because of GraphQL schema, there are beneficial features such as API evolution, validation, type checking, and auto documentation, so that is suitable for rapid development. Last but not least, there is a huge community and enormous variety of different tools. That is always a plus. But enough talking. It's practice time. We will build an app using all main GraphQL concepts. As for tech stack, on the backend we have Node.js, GraphQL Yoga for GraphQL Server, and Prisma for database connection. As for frontend, we will use React and Apollo client. So, let's take a look at our server-side application. Here, we will write a schema, some resolvers for queries, mutations, subscriptions, and examine code structure. The idea of the app is to create and view products and write some reviews to them. Firstly, I should mention code structure. We could write all code in one file, but it would harm our readability. So, I divided it into smaller chunks. Right now, we are looking at the entry point of our app. Here, we import our defined schema from a file, then we combine all resolvers into one object and pass them to create server function from the GraphQL Yoga library that returns a server instance. After returning a server instance, we should invoke a method start on it, and our app becomes ready to accept connections from clients. Second essential part of our server is schema. It is defined in a separate file, schema.graphql, and here we got all types of operations that are available to the clients. Right now, we've got only queries, so we describe them in a type query. We've got two of them. Version, that simply returns the current version of the app with the type string, and products, that return the array of objects. Objects should also be described as separate types, so rewrite a definition right beneath. It has three fields: a unique ID, title, and a price. Exclamation sign at the end of the line means that the field could not be nullable. After defining a schema, we should write some corresponding resolvers. For that, we move to the file query.js and see at the realization. So the resolver's task is to return all data client requests from schema. It can populate it in any way, such as fetching data from a backend or any other third-party API. Query.js file has all possible resolvers that are related to a query type. Right now, we've got two queries: version and products. The last one returns a simple array of all our products. It is mocked up for now, because we don't have a database for it, but we will add it later. Resolver takes 4 arguments, but for now we're interested only in the last one. Info. Info contains information about the execution state of the operation, but it is useful only in advanced cases, so we don't need that yet. All other arguments will be used and described later. So, let's run and test our server. For this, let's start our entry point. After starting our server, there will be a link to the playground of the GraphQL. Let's navigate to that. And here we will see an analog for Postman, except it is made for GraphQL. Firstly, it allows us to search through schema in the docs that is auto-generated. So we can see that now there are only one root type available. It is query. If we navigate to it, we will see which queries can we make. It is a version and products. And if you don't know what product is, we may navigate to it and see what fields it includes. How about writing our first query? So, I want to know the version of the app. For this, I'll write a keyword query, give a name to the query, for example, get version, and specify which query I'd like to run. I'd like to run version. With some nice autocomplete, we get the query, and after hitting run, we get the result. As we see, we get the exact data we queried. I queried version, I get version, and the result is typed correctly. So, let's get the list of our products. For this, I will add another query, name it get products. Say that I want products, and if I query not a simple type such as string of an integer or float, I should specify which fields I'd like to get. So I'll get ID and title. Then select which query we want to run, and voila, we've got our products in the result. As we see, we've got only the fields we queried. But if I want to add price, for example, we will see the price as well. Next, we will connect our app to the database using Prisma and write our first mutation. For database connection, we will use an ORM called Prisma. It allows us to define database models for our app and then conveniently manage data. For that, we create a folder called database with the file schema.prisma in it. Here we define all our configurations and data models. In order to connect to the database, Prisma has to know where to connect. For this, we create a data source type called DB with two fields: provider, that is the type of database we use, and a connection URL. As database, I chose a local database Postgres, but Prisma supports a variety of other databases. As for the URL, it reads database URL from the .env file that are located next to the schema.prisma file. Here I connect into the local Postgres database, but you may specify any other connection URL as you wish. Then we have to add our data models. For now, we have only one, product, with the similar types as in schema GraphQL. We specify the type of a field, such as int, string, or float, and may add some additional attributes. Attributes modify the behavior of a field or a block. For example, the modifier ID says that ID should be used as a primary key, and by default, it should auto-increment. There are many more attributes, but for now, we'll use only these. To start using Prisma in our code, we should add package called Prisma Client. Let's add it. I already done that, so I won't install it. So it allows us to generate client based on the configuration schema.prisma file, and then use it everywhere in our code. To generate client, we should specify type generator with the name client and two fields of this object. The first one is a provider, Prisma Client.js. It determines which assets are created. It is language specific, so with JavaScript we should use Prisma Client.js. And the output is a place where our generated client resolves. After completing the schema Prisma file, we should add Prisma CLI package to generate client and push our models changes to the database. For that, let's try run Prisma. I already done that too. So the last step before generating our client is to specify path to our schema.prisma file in the package.json. For that, we should add field Prisma with the field schema in it and the path to our configuration file. So let's push our changes to the database. For that, let's run Prisma db push. That will take our models and push it to the database. It also auto-generates client, but let's regenerate it with the command Prisma generate. Yep, we see that based on our configuration file, there was generated a client in the generated folder. So, to start using the generated client, we have somehow connected to our GraphQL app. For this purpose, let's include it in our entry point by importing the generated path right here. We import the Prisma client class, so we have to create a Prisma object and then pass it to our context. Context is an object that is being shared across all resolvers, so it is a useful place to pass down our database client. Let's now look at our updated resolvers. Here we see that the products are now reading data from the database, not from mocked up data. In order to find our products, we have to call the context.prisma, then select which model we would like to query. In our case it is product, and then evoke query methods on it. In our case it is find many. But there are many more of them for every need. We do not specify any options because we want all products to be returned, but there are a variety of filtering it based on your imagination. Secondly, let's create a mutation. For that, we should define our root operation mutation at our GraphQL scheme. Here we got it newly created type mutation with the one field in it, create product, that takes an argument, object product, with title and a price, and returns a product. As we see, the argument type product typed as input. It because it goes to the parameters of the mutation or the query. Let's back to the resolvers that conforms our scheme. Right here we got a newly created file mutation.js, where we created corresponding create product mutation. Here is where the args argument kicks in. There are allocated all input of our mutation. In our case, it is object product with field, title, and price. Then we should save it to database. In order to do that, we call context Prisma, select our model, and invoke query methods create. As an options, we pass down there an object with the field data, and to the data we provide our product from the arguments. Let's test it. For that, I'll run my entry point, navigate to our playground. We got some queries left from the last time, so let's check what are the products right now. As we see, there are none. So let's create one. For that, let's use keyword mutation. Name it as create product. Then we call our mutation, use it as a function in JavaScript, and pass down the argument product. Here we should specify title. I'll call it product and the price. For example, $10. Also, we should specify which fields are returned. I want to return ID, title, and price. So let's run our mutation, and as we see, we created a product with an ID 10 and we got the result. So we'd like to query products for that, and voila, we get the created product. But how do we know if the product is added to the database, except blindly trusting to our backend? For that, there is a tool called Prisma Studio. It allows us to inspect our database, see models, and much more. For that, let's run Prisma Studio. It will open up nice Prisma Studio in our local host, and here we might see what models are available. Let's navigate to the product model and see that here is a newly added product. Let's add another one, for example, product 2 with price 12. Navigate back to Prisma Studio, refresh our data, and that's it. Here we got another created product. Here we might use some filters, select only several fields that we need, like use pagination, manually add record, and delete data if we want. Now let's create a model subscription, so that we track our newly created products. Subscription uses WebSocket connection under the hood, and instead of returning specific data, it returns an async iterator, which is used later by the server for sending data to the client. For these purposes, we will use a pub/sub technique implemented by the GraphQL Yoga library. Pub/sub refers to a technique used to create a messaging pattern, where some parts of the code publishes events or messages, and the other parts of code subscribes and be notified about the events. Firstly, we will create a new pub/sub instance. Then we will pass it to the context as we did as a Prisma, so it becomes available from any resolver. Then let's modify our schema GraphQL file. Let's add a new root type operation subscription with the field new product that returns a newly created product when the event is fired. After that, we will add a subscription resolver. In our case, subscription resolver just listens to emitted events from PubSub called new product and return the async iterator. Subscription resolvers are wrapped inside an object and need to be provided as a value for a subscribe field. You also need to provide another field called resolve that actually returns the data from the data emitted by the async iterator. In our situation, resolver function just forwards data to the client. Now, let's test our subscription. For that, let's again run our entry point and navigate to our playground. Here we got our mutation create product, and we have to open another playground and enter the subscription. Here we say what subscription product, what kind of subscription we would like to use and what fields we would like to see on the newly created subscription. After running our subscription, we are now listening to the event. And let's get back to our create product mutation and create a new product. As we see, we created product with ID 12, title and price. Let's see what our subscription returned, and as you see, it returned a newly created product in the real time. So let's create another one. For example, call it product 3 with the price 15. And see that our subscription also returned our newly created product with the title product 3. The next step of creating our app is to add reviews to the products. Each product will have one-to-many relations with review. For this purpose, let's extend our Prisma schema and add another model called review. It has field ID, text, and a link to the product. On the ID, we have the same attributes as in a product. It's a primary key, and by default, it's auto-increment. But we also add another attribute called relation that shows the connection of this model to another. It uses as a field a product ID, and product ID references the ID field on the product. After every change of schema, we should push our changes and generate new client. So let's push our changes and generate our file. Let's also edit our GraphQL scheme and add dependencies to each of the models. Product type now has an array on reviews in it, and the review has a parent product type. For these fields, we should now implement resolver function so that our dependencies resolve correctly. For that, we should add a new resolver called review with a function product in it that returns a product for a parent review when we want to query a product from a review. The parent argument here represents the result of the query on the review type, so we can find resolver reviews from the database. Then we invoke the findUnique function and pass it the result of the parent resolver. After that, we invoke function product on the result to get the product dependency. The same logic is followed up in the product resolver. Here we got the function reviews that will find all reviews for the product. We got it from the parent, then we'll find unique product and get the reviews. Then let's add a mutation for creating reviews. Let's update our schema, add a new mutation, create review, that takes a review input. Here we got a text and the references product ID that references the product. As a resolver, we have here create review function. It has some additional features. Firstly, we check if the product exists. We try to find one product with the provided product ID, and if it is present and return type is not undefined, we assume that the products exist. If the product exists, then we should create a review that connected to this product through the product connect and providing a product ID to this object. So let's test it. Let's run our Let's open our playground and see what products are available. Let's create a review to the product with ID 12. For that, we will call create review and pass the review object. As the text, we will provide review 1 and product ID. Let's specify 12. Let's return the ID and the text. After creating a review, we see that it's successfully created. Let's now query it from the products type. For that, we should add a field reviews and specify which fields I would like to query. Let's run this query. And as we see, in the first product with ID 12, we got our newly created review. And in the second one, we have an empty array. Let's also create a review and immediately get the product as a result. Let's get its ID. So we create a review and we get the result product. That is because of our connection dependency resolvers. Last features for our backend are filtering, pagination, and ordering. Firstly, we have to add parameters for our query products. Let's start with the filtering. We provide an optional parameter filter to the query typed as string. In the resolver, we check if the filter argument is present, then we create a where condition and try finding product with the provided title. To do that, we should provide the where condition to define many methods. If the filter is provided, we will return all the products with the given name, but if not, we will return a full list of all products. Secondly, what about pagination? Let's imagine we have a huge list of products that don't fit into one page. We would like to split it into several smaller pages to improve our performance. To achieve that, we should provide the amount of product that client has already seen and the size of the page. For these purposes, there are arguments skip and take. The skip argument shows how many records in the database we should skip, and after skipping those values, the take argument shows how many we should take and return to the client. So, after receiving these arguments, we should simply pass it to the Prisma, and it performs magic. Also, we would like to get the full count of the product, and that is simply done by calling methods count on the Prisma product model. After doing that, we should also edit our scheme so that products return not simply a list, but an object, type products, with a count and a product list in it as we did before. The last but not least is sorting. For this purpose, we should provide a parameter called orderBy. It is an input that has two fields, title and sort, that shows which exact field should we sort by. Also, it shows in which direction should we sort, ascending or descending. In our resolver, we just simply pass the orderBy object to the Prisma and Prisma handle it itself. So, let's test it. Let's navigate to our playground and see what products are available. As we see, we have 5 products, product 2, product 3, and GTA, computer and table. Let's now try filter them. We would like to see only the GTA product. For that we provide filter string as a GTA. Voila! We've got the one object in our product list. Let's also see if count works correctly. It should return 5, no matter what filter we provided. That's it. Now, let's test the pagination. For that we provide parameter take. We want to take 2 products and skip, for example, also 2 products. As a result, we skipped our first 2 products and got the GTA and the computer. And let's order them. I want to order it by ID. For that, I'll provide an order by object where I specify ID and specify the direction desk. As you see, DJ now is first because it has bigger ID. If I want to sort it by title in ascending order, it will provide us another products because our ordering has been changed. If I remove skip and take, we'll see that the computer GTA are the first 2, then it goes product 2 and product 3, and the last one is table. Let's move to our client. It is written in React and for GraphQL uses library Apollo, in particular Apollo Client. Apollo Client provides us with convenient features such as GraphQL communication in memory cache, so we don't need any store libraries such as Redux. Also, for real-time communications with sockets, we need library GraphQL VS. It allows us to take full advantage over subscriptions. To create connection with our GraphQL server, we have to use HTTP link and GraphQL VS link classes. Split function is used to differentiate real-time subscription and simple HTTP queries and mutations. getMainDefinition utility function understands if the requested operation is a subscription, so it may be handled separately. So, firstly, let's create our connection to the server by calling the classes HTTP link and GraphQL VS link, passing our server URL. Then we split our operation using function split, and after that we create our Apollo client, passing down our splitted link in memory cache and client type definition. After that, we wrap our React application into the Apollo provider, passing down the client. So we might use Apollo hooks for queries, mutations, and subscriptions inside our React app. Let's take a look at our GraphQL requests from the client. Here we use the function GQL from the Apollo client library that passes string where the GraphQL code is located. Here we use the same syntax as in the playground, specifying the type of operation, its name, its parameters, the name of the operation, and the response fields. Here we got the query get products, mutations create product, create review, and a subscription to the newly created product. Now let's move to our routes. Here I got a header for navigation and 2 routes, one for rendering our product list and the second for adding new products. Header is a simple component with the links to the other pages of our app, in particular products and add product link. The product list component is a bit more complex one. It is used for rendering product cards, fetching data from the backend, and subscribing to newly created product. For fetching data, we use hook useQuery. It may only be used in the scope of our Polar provider. And added arguments, we provide our query that we want to use. It's the get products and an option object. Here we pass our variables. In our case, it's order by. In the result, we get the information about the loading state, error state of the query, its return data, and subscribe to more function. If our query is loading, or the error has occurred, we show some corresponding text. If everything is okay, then we render our products item from the data, product lists. In order to subscribe to more products, we have to call subscribe to more function once, while the component has rendered. For this, we put it into the useEffect hook. As an argument, we provide the document as a name of our subscription and the update query function. This function is used for updating local cache store as a Redux reducer. Here we got the previous state of our cache and a newly received product. Then we have to define how to connect our product to the existing store and return it. List is using component product item for rendering our cards. Here we show the title, price, and the product reviews. The product reviews are rendered in the review list. Here we just simply render our review texts and a form add review for adding a new review. But before looking at it, let's firstly take a look at add products form. Here we got a simple form for entering a title and a price in the inputs and a submit button add product. It has a handler on click with a handler product create that calls our creating mutation. This mutation is defined using the useMutation hook. At the first argument we provide our mutation called createProduct and an option object at the second argument. Here we got two fields. The first one is refetch queries. It's an array of queries that should be run after our mutation completes. In order to see our newly updated product list, we like to run the query get products after our mutation completes. As variables, we pass down our common order by option. The second field is onCompleted. It's a callback that runs after our mutation has been completed. And in our case, it just redirects us to the main page. useMutation returns a function, createProduct, that calls our mutation and similar to the useQuery hook, loading and error information state of the mutation. So after clicking the add product button, we call our handle product create function that calls our mutation and pass down the variables our newly created product from the form. Let's now return to add review component. Here we got almost the same component as an end product, except for the useMutation options. Instead of refetching our reviews after completing mutation, we call the function update to apply manual changes to our cached data after the mutation. In this function, we've got two arguments, the current cache state and our created review. After that, we call a method readQuery on the cache. It works as a normal query, but instead of calling our server, we call the local cache. As a result, we get our current products. Then we add newly created review to the product with the product ID. and use write query method to locally update the cache with the query getProducts. So now let's test our application. For this, we navigate to our working app, and first thing we see is our root page with a product list with product cards, some fancy design, and here we see that each card has a title, a price, a list of reviews, and ability to add some new reviews. But firstly, let's add a new product. For this, let's navigate to Add Product Form and enter the title. For example, I want to add a chair and the price for $80. After clicking Add Product, we see that our newly created product chair is added at the start of our list. Let's now add a review for it. Let's say it's a bit small and it's cheap. Here we are. We've added some reviews to this. And now let's test our subscription. For that, let's open a new tab. And from this tab, let's add another product. Let me say an apple with a price of $3. After adding an apple on this tab, let's navigate to our first and see that the product was added via subscription on this one as well. Here our lecture comes to an end. We did a great job meeting core GraphQL concepts and writing code, both on front-end and back-end sides. I hope everything was clear, but if you would like to dive deeper, I would recommend these sources. The first three are just library documentations, such as GraphQL Yoga, Prisma, and GraphQL overall. And the fourth one is a cool collection of guides, which has a lot of different GraphQL tutorials with different tools. Thank you for your attention. See ya!